Good morning. We have solved 26 problems. Let's continue with next one. Okay, let's see. To sum input array sorted. Given one indexed array. Okay, interesting. It's not zero indexed. Ascending order. Find two numbers so they add up to a specific target. Okay. Return the indices added by 1 as an integer array of length 2. Oh, okay, I see. Because it's one indexed. There's only one solution. Your solution must use only constant extra space. Alright, let's see the example. Target 9. This will be indexed 0 and 1, but they want index 1 and 2. Yes. 0 and 2, 1 and 3. So is it guaranteed? Okay, it's guaranteed that there is exactly one solution. So there will always be a solution and only one. Okay. Constant extra space. So the numbers are sorted, non-decreasing. We have a target. Okay, so first idea is that we will use two pointers, one from the beginning, one from the end, and then we go towards the middle because it's sorted. So let's see, we see 2, we see 15, we see this is bigger than target. So then we move towards the middle, we see this is still bigger than target. We move towards the middle until we find it. And let's say if target was 13, then that's it. I guess we just start from the end and go towards the middle. Oh, I see. Okay, so here's the thing. If let's say target was 12. Okay, we see 2 and 15. 12 is smaller, we move 15 to the left. Okay, now we have 2 and 11. That's 13. Target is 12. So which one are we moving? Are we moving the left pointer or the right pointer? So that's a problem. Exactly one solution. 12. Let me make up some new examples here. Okay, so we look at 1 and 15, that's bigger. So in the case that the red pointer is pointing to a number bigger than the target, then we know for sure that we want to move that red pointer. But the problem is once the red pointer is smaller than target, then what we are at 1 and 7. So now how do we decide if we're moving left or right pointer? Oh, I see. Okay, so the algorithm goes like this. So we're at 1 and 7, that's 8. So 8 is smaller than 9, which means we needed to go bigger. So we need to move left pointer. And if 1 plus 7 is 8 and the target is smaller than 8, then we will move right pointer because we need it to be smaller. Okay, now we know. All right. Let's see, we have a left pointer starting at 0 and a right pointer starting at length of numbers minus 1. Well, left is smaller than right. Yeah, there's no point to check. Well, there's no point once left crosses the right, because we already checked. Okay, so while left is smaller, oh sorry, that's not Python syntax. Then if numbers left plus numbers right is bigger than target, then we move right pointer, we decrement right pointer. If numbers left plus numbers, well, we might as well save that as a sum so we don't calculate that. Of several times. If it's smaller than target, then we move left pointer to the right. If it's exactly the target, that's when we return the indices as an integer array. Then we return left plus 1, right plus 1. I am curious to see if this actually works, because in other languages we need to have this return outside of the loop for it to work. So I want to check this first. Oh, that works. Interesting. Oh, okay. So very efficient. Your solution must only use constant extra space. I am using only constant extra space, just left, right, and sum. That's all the variables I'm using. Alright, I guess this is not gonna take that long. I thought it would take much longer since it's a medium problem. Okay. Am I missing anything? Okay. Constant extra space. Alright. Okay, so let's do time and space analysis. So time, we are using 2 pointers to traverse from the left right end towards the middle, and at each step we are doing this sum of left and right, and then we will only move 1 pointer at each loop, each round. So it will at most traverse all numbers. This is a linear solution. And constant space, so linear time constant space, which is ideal, the optimal. Let's see. No follow-up questions. Alright, let's have a look at top solutions. I see. The time might actually be even smaller than linear if we can do log, since it is sorted. Okay, two-pointer solution, left, right. Okay, yeah, exactly same solution as I have. Dictionary solution. If target minus current number is in the dictionary, then we return. Otherwise, we put current number in the dictionary as key and the index as value. So we are storing all the numbers in the dictionary as key, and then we have their positions as value. And when we check the next number, we will check if target minus current number is already in the dictionary, which means that those two numbers will give us the target. If that is the case, then we want to get the position of that number that's already in the dictionary plus 1, and then current numbers index plus 1. Okay, perfect. Binary search. Since we have sorted, so let's see for I in X range. What is X range? That's a new thing. Let's learn that. X range. Generator object only by looping. I don't think I understand this. Okay. So both left and right starts with I plus 1, okay? Oh, no. Left starts with I plus 1, right starts with the last. Okay. Can we find the middle? And if the middle one is... Oh, I see. Alright. So still using this as an example. So we have left and right. We have this temp, which is the number we are looking for. That will be target minus current number. Okay. Okay, so I starts at 0, but this starts at 1. Okay. So I is 0, left is 1, right is the last index. Temp is 9 minus 1, which is 8. Okay, so alright, I see. So we wanna we're at the first number, we want to see if there is an 8, which will give us the target. So left and right is covering this part of the array. So we look at the middle one. If the middle one is what we're looking for, we will return. Otherwise, if the middle one is smaller than what we're looking for, then we know we wanna search in the right half. If it's bigger than what we're looking for, then we wanna search in the left half. Oh, so for each of this, so this little while loop is gonna run in logarithm time, but we are actually having a for loop outside that's gonna go through each number. So this will be linear times logarithm. So that will actually be like a log n. So that is not as good as just linear. Oh, see. 2 pointers, linear time, constant space, dictionary, linear time, linear space, because we're using a dictionary, binary search, and log n time, constant space. That's exactly what I thought. Okay. Okay. Anything else that we should look at? No, same solution. Oh. 2 pointers. This is good tips. So we can always think about binary search, 2 or 3 pointers, a sliding window, and traversing from the right. Just typical tricks. Okay. Okay, I think that's it for this one. Short and sweet. I'll see you in the next one.